The new section today is 3.3, and this is kind of like the last round of showing you how to add numbers and subtract numbers and multiply and divide and do all that kinds of stuff. After this, it's kind of like you just end up using a calculator for the most part if you don't know how to do it in your head, which maybe sounds like yes, but I found the more stuff I can do in my head, the faster I can go. So I'd recommend, try to do math in your head as much as you can, and you'll find that you get better at it with more and more practice, and it just helps you speed up. But the new part today is problem solving, and they're calling it sums and differences of decimals. So sums and differences. So sum is when you add them together. Differences are when you subtract of decimals. Some examples, first of all, really before we're actually doing any operation, is when we talked about this yesterday in the notes, if you have a 0.5, that's the exact same as 0.50, right? They're both 1/2, they're both halfway to 1, and that's going to be the exact same as 0.500. So you can add zeros to the right of a decimal point without changing the number at all. Agreed? And I don't think I'm going to write that unless you want me to, but as long as you're to the right side of a decimal point behind all the numbers, you can add zeros and keep it the same. So then my first math problem is going to be if we were to say 5.71 plus 3.8. Essentially we're doing a little more than 5 plus a little more than 3, right? So the reason I wanted to say it that way is you need to line up the decimal points when you're doing addition and subtraction problems. So if I do 5.71 and then a plus, I have to do my decimal points together. So the 3 will be right under the 5. Comment I want to make here is it has to look that way. One, it can't be 5.71 and then a 3.8 like that. That's not going to work because you'll end up adding the 5 and the 3 together. The reason I did my example up above with adding zeros after the decimal point is we can take and we can add a 0 right here after the 8. Agreed? They call that officially annexing zeros, like adding on zeros. You don't need to know that at all. But now when we add them together, I have a 1 plus 0 gives me
1.
7 plus 8 is
15, carry the 1.
Yep, 15. So I have my 5 for my 15, carry the 1, decimal point, and then a 9. So some of you are real proficient at it. Yes? Some struggling maybe. Questions on those? But you're going to get a section on the quiz, going to get a section on the test saying, hey, add these together or subtract these or something like that. So 9.51 is the answer there. Next one, I'm going to have a 4.29 minus a 1.1. So we have the same sort of things. With subtraction, you must line up the decimals. 1.1 like that. And now we're subtracting. Can we add a 0 after the 1? Yep. Even though it's subtraction, as long as there's no numbers after it and it's to the right of a decimal, you can add zeros. And now we do the same thing but subtract. 9 minus 0 is 9. 2 minus 1? 1. Put in your decimal points, and we have the 3. So 3.19 is our answer. Good still. Kind of upping the ante a little bit, making it a little bit tougher. If I were to do a 8.4, so my third example, 8.4 minus 3.67. So now when I write it out, I have a 8.4 minus 3.67. Do we want to add any zeros in here? You could. If you know what you're doing, maybe you wouldn't even do that as a first step. But you could say we're going to put a 0 right there. You could look at it as though we're not. But if I try to do 0 minus 7, that doesn't work. Agreed? Gets me down to negative numbers. So what do we do to solve the problem? Go for it, Hank.
4 doesn't appear, so you take away 1 from the 8, make it a 7.
Ooh. We don't want to mess with the 8, though. We want to start with the 4. Take 1 away from the 4, and you get a 3. And now this is going to make that digit a 10, right? So the 4 becomes a 3, then the 0 becomes a 10. Now we could do 10 minus 7 is 3. And now we get the same problem in that next digit. So here then we'd take the 8 and make it a 7. My 3 then would become 13. 13 minus 6 is 7. 7 minus 3? 4. So final answer would be 4.73. Usually you're probably not going to have to do it twice like that. You'll end up just borrowing from the 4 to make the last digit a 10 or something. But it could be that you have to do it multiple times. You okay in the third one? And the last two are going to be the same steps, but they're going to just look a little bit different. Or it's the same concept, maybe I should say that. So my second to last example, I'm going to have it say solve. And we're going to kind of combine what we were doing before with this. So I have a x minus 4.92 equals 8.1. So what do we do to both sides to get x by itself? Perfect. So x, they subtracted 4.92 from x. We need to do the inverse of that. Kind of looked at as the opposite by a lot of people. So we're adding those two together. So now I have a 8.1 plus 4.92. And when I have that, you could add in a 0 if you wanted to. You could nx a 0. 0 plus 2 is 2. 1 plus 9? 10. So we have a 0 there. Carry the 1. And then we get 13. So 13.02. Questions on that example? All right. Final one. We could say the last one is x plus, maybe I should have said solve, but x plus 9.17. I'm going to go back and say solve. Feel free to leave yours if you want to. It's totally fine. But this one here, solve. Now we have a x plus 9.17 equals 14.58. And they added 9.17 to x, so to undo addition we must subtract. So we subtract 9.17 from both sides to keep it equal. I'm just going to line up things right here on the right hand side. Now as we do our subtraction, 8 minus 7 is 1. 5 minus 1? 4. Then a 4 minus 9. That doesn't work. So you could look at it as a 14 minus 9, or you could cross out your 1 and make it 14. But that gives us a 5. So 5.41 for a final answer. That's it for the section. Feeling okay? If you're struggling with that, please ask. You know, it's kind of the final hurrah. Let's get it right. Don't suffer in silence.